So today we are going to start with the new category of the particles or subatomic particles. We can say that. So leptons are the new category for the particles, and these are also fundamental particles. When we use the word fundamental, so it means that these are the fundamental particles, just like the fundamental units, fundamental quantities. If we take time, so time is fundamental quantity, right? And we combine length with time to make velocity, right? So same goes with the fundamental particles, that fundamental particles combine and they make some other particle, right? So if we talk about the leptons, so leptons are the fundamental particle basically. So it means there will be no interference of quark in this section, right? So in leptons, we are not going to discuss about quarks. Fundamental particle means there will be no quarks. And we discuss about 6 different flavors for quarks. So same goes for the leptons. There are also 6 categories for leptons. The first one, let's suppose we consider. First one is the electron. So electron is also in the category of leptons, right? The next one is neon. Third one is tau. And the symbols for these leptons are like, for electron, you know that E with minus sign. Then muon is derived from the letter or that prefix, we say that mu, that symbol of mu we used to draw for different quantities in our topics. And this tau symbol is also used for the quantity torque or moment, right? You already discussed that because in some boards we used to write with capital M, and in some boards we used to write with that symbol tau. Like in federal boards, we used to write a torque with that letter tau, but normally it will be moment, so we write capital M. And there are 3 other categories of the leptons. And previously, we discussed about one other form, that is neutrino, right? Okay, so the next one is electron neutrino, muon neutrino, and tau neutrino. Okay, so these are the 6 categories of the leptons. And one more important thing, because let's suppose if they ask you to define leptons, so you just simply say that leptons are the group of fundamental particles, right? And they are not made up of any other particle, just like quarks. Okay. And if we talk about some other properties of these leptons, so electron, uh, we have electrons, so we have basic idea of electron. We already studied much about electron. So muon and tau, both are like similar to the electron, but slightly larger mass, right? So if we talk about muon and tau, are most likely to be electron, or we can say that are very similar to electron, but slightly larger mass. And the second thing, if we talk about electron, muon and tau, so the charge for electron, muon and tau remains the same because it is like the electron, so charge will also be the same. That's why there is a minus sign over it, but they will be slightly greater in mass as compared to electron, right? And some more properties, leptons interact with the weak interaction. So in this point, we are talking about that leptons interact with weak interaction. Weak interaction means we are talking about weak forces. And what are the weak forces? The electromagnetic and gravitational forces, right? Electromagnetic and gravitational forces. So when we are working with the weak forces like the electromagnetic force and the gravitational force, so in that purpose, we are using electrons, muons, and tau, right? In this chapter, quark is the most important topic as compared to the other, because you observed that was there are charges for that, and they actually combines to form proton and neutron. So that was the most important topic. Leptons and other are like the theoretical one, and there are no detailed explanation or the charges for leptons. But there are some properties. Let's suppose if they ask you to write 2 or 3 points for leptons, that how leptons are different from quarks. So that is important.
Okay.
So leptons do not interact with a strong force. So there is a different quarks interact with the strong forces like the nuclear force and all that things, because electrons are moving away from the nucleus or around the nucleus. So that's why electrons are different from proton and neutron, and that is the reason that we are using in gravitational force and electromagnetic force. That's why electrons are free to move in conductor also. If we talk about the quarks, so quarks actually interact with the strong forces, right? Like the nuclear force. Okay. So this is the concept of lepton. So just remember the names of these leptons and some properties of leptons and the definition of leptons, right?
Okay.
After leptons, we are having another category, that is, so next category is related to baryons and mesons. So initially we started from the concept of hardons. So hardons contains the quarks, and in that hardons we are having two particles, proton and neutron. So if you continue with that concept, so we already discussed that hardons are the group of subatomic particles, group of subatomic particles, and with the help of these particles we are making quarks. And those groups can be divided into different forms, and those groups will be like the baryon. Baryon is the category in which we are working with three quarks, because initially we only discuss about the formation of proton and neutron, right? We didn't differentiate like this, that why we are using the upper flavors like up, top and the charm, and why we are interacting with the lower category, that down, strange and the bottom. Okay, sorry for interruption. So basically we initially discuss about the hardons, and you know that in hardons we discuss about proton and neutron only. Okay,
Okay.
and after that we discuss their formation, right? And after the formation, we have six different flavors of quark, and we just combine the upper category and the lower category to make just proton and neutron. But if we want to differentiate between those upper and lower categories, so there are two more categories, right? The first one is the baryon and the second one is the mesons. They are also, we can say that, are the categories of the quark or the categories of hardons, right? So the first one is the baryon, and in baryon we are working with three quarks.
Yeah.
And if we talk about mesons, so in mesons we are going to work
Your
with,
voice is glitching a bit.
okay, let me check. Okay, now it is clear. So
Okay.
yes, so in baryon we are only working with the three quarks, right? And in mesons we are working with one quark and one anti-quark, right? So there is a pair, basically pair of quark and anti-quark. So these are the two categories, and these two categories we can say that are the categories of hard-ons. If we want to differentiate specifically according to their specification, So these are the two categories. And if we want to take the examples, that what are the examples of baryons and what are the example of mesons. So for baryons, the example we already discussed, that is only related to the quarks, and those are the proton and neutrons. So proton and neutrons are the example of baryon that works actually with the three quarks. And if we only talk about the pair of quark, like one is the quark and second one is the anti-quark. So there are two more examples. The first one is known as pions, and the next one is kaons. These names are might be slightly difficult, but they never ask about such specification, but I am writing the name because you must know about the difference. Mostly they ask about that what is the difference between leptons and mesons. So you just write the definitions, that in mesons and baryons, these are the subcategory or are the categories of hardon that actually made up of or made from the group of subatomic particles called as quark, right? And for leptons, we already discussed that those are fundamental particles, and those particles cannot be derived from quark, right? So there is a complete clear difference between leptons and quarks, right? And this name pion actually derive from the word pi.
Okay.
So we just write the symbol of pi with positive sign and kaons. So K word gives you the concept of kaon. So that's why K positive. Because we are working with proton and neutron, so we are working with positive charge. In leptons we are working with negative charge. Okay. Okay, so we discussed about hard-ons till now, right? But it is also possible that there will be also a category of anti-hard-ons, right? Because we know that there will be anti-proton, anti-neutron that we already discussed, so there will be anti-pions and anti-kaons also, right? So if we talk about one more category related to the quarks, so that will be anti-hardons. So in anti-hardons, we are having again same categories with word anti, anti-baron, anti-mesons. And if you want to write their composition, so in baryon, we are combining three quarks. So in anti-baryon, we are going to combine three anti-quarks, right? Because we are working with the
Yeah.
anti category. So in normal category, if we are using quarks, so in anti-baryon, we are combining three anti-quarks. And for the second anti-mesons, we need to combine again quark and anti-quark pair, because there is already a category of anti, right? So that original quark converts into the anti, and anti is going to be converted into the normal quark, right? So the second category remains same as we discuss in normal mesons. Because mesons are already forming with the help of pair of quark and anti-quark. So you know that if we just reverse the quark, so the reverse of the quark is anti-quark, and again the reciprocal of the anti-quark is quark. So they will remain same. Okay. And if we want to write the examples of these categories, So if you talk about the example of antibaryon, we are having antiprotons and neutrons. And in the category of antimesons, what will be the example? Antipions
Okay.
with negative sign. And the last one, antications.
Oh, okay. So like the pions and kaons are for anti-mesons, and then
Yes.
antiprotons and neutrons are for
Yes.
antibaryons.
Yes, so this is the only
Okay.
difference because all the things, all the concepts, all the name of the particles are like the first time and are the new one. So it takes time to just write down their names and know about their categories. The concept is not much difficult, but it is like the new topic, so it will take time to discuss all the particles names, all the specifications. So these are the categories of
Oh,
quarks, hydrons, and the leptons also, right?
yeah.
Okay.
Is that it or is there more?
Just one more thing, then we will start solving some questions because in this chapter, previously we start with the concept of that Rutherford. So that nuclear physics is also slightly included in this chapter. So half is
Okay.
chapter from that nuclear part and half of this from the particle run. So one more thing that is related to your category of the particles, that is just a now composition, or we can say that the quark composition. So in quark composition, now we are going to talk about beta positive decay and beta negative decay, because previously we discussed about proton and neutrons only. So for this time we are going to discuss about beta positive and beta negative decay, the composition of beta positive and beta negative. So we need to discuss the composition of beta positive and beta negative. Let's suppose if we start from beta positive first. So your composition will be like, so beta positive decay takes place when a proton turns into a neutron, and during this process it will emit positron and electron neutrino. Okay, so basically we are talking about beta positive decay, right? And in beta positive decay, when a proton turns into a neutron,
Yeah.
So during this process, when proton is actually converting into neutron, so it will also emit positron and electron neutrino. Okay, so it means that during beta positive decay, what is the main process of beta positive decay? We are converting proton into neutron, but during this reaction, we are also getting positron and electron neutrino, right?
Yeah.
And second thing is a proton turns into a neutron because an up quark turns into a down quark. Okay, so basically, previously, before the chapter, before the concept of particle physics, we are just talking about the conversion. We are just talking about the experiments and the reactions, but we never discuss about their background, right? So basically, when proton is converting into a neutron, so what is the background science behind that? That up quark is actually turns into the down quark, right? Because
Yep.
we do that, we are making proton with two up and one down, right? And if one up quark is convert into the down, so that will make neutron, right?
Yeah.
Because we discuss about their formation, and according to that formation we know that two down and one up makes neutron, two up one down quark makes proton. So when proton is actually converting into the neutron, so the basics behind that is your up quark is converting or is turning into a down quark, right?
Yeah.
So if we talk about the equation, so equation will be like your proton is converting into the neutron, plus we are getting positron. Remember that positron opposite of electron, right, with positive charge,
Yes.
plus electron neutrino that we discuss in lepton. And your final equation or your final composition will be like this. If we are using two up quarks initially, we are combining two up and one down quark to make proton. So their formation will be changed and they will convert into two down and one up quark. So this is the conversion that take place during beta positive decay, right? So this is for beta positive decay. And if we talk about beta negative decay, so for beta negative decay, we have to follow the same process with different specification. In beta negative, when a neutron turns into a proton, it will also emit electron and anti-electron neutrino. Now you got the concept that in beta positive we are converting proton into neutron, and in beta negative we are just converting a neutron into proton, having different elements or different subatomic particles, right?
Yeah.
And now you also got the second point. In the first point we discussed, or in the concept of beta positive decay, we discussed proton turns into neutron because an up quark turns into a down quark. If we reverse that process, right, that down, if down quark is convert into the up quark, so again we are making proton, right? If we just reverse this process, okay, so again we are
Yeah.
converting into proton, right? So your
Yes.
one down quark is actually converting into up quark. And you also got the idea of the formation, right?
Yep.
You need to draw that formation in the reverse order. So your equation will be n is converting into proton plus electron plus electron neutrino. It means that, okay, so electron neutrino is common in both reactions. So these are two type of quark composition, that is for proton to neutron conversion and neutron to proton conversion, right?
Yeah.
So any confusion?
No, it's clear.
Okay, so now we have enough knowledge about particle physics, and these are the all content that we need to cover in this chapter. Let's try one paper to get the idea that how questions are going to be in your final exams from this chapter. Okay, so this is the question that is from year 22, Feb March 22, paper 2, variant 2, right? So in the first question, they are asking with a reference of the particle that a nucleus of sodium 22 decays by emitting a beta positive particle. A different nucleus is formed by the decay. State the name of another lepton that is produced by the decay. If you remember the experiment that we discussed in the last topic of the chapter, so there are two compositions, beta positive, and beta negative, right? So they are asking about the name of the lepton, right? So if we want to know about the name of the lepton, we need to first know about the leptons, because leptons we studied today So these are the leptons, right? So which lepton you find in the beta positive and beta negative decay? That is electron neutrino, right?
Yeah.
So now you can see that exam they are also asking about the name, right? But for that you need to know about the whole structure and whole concept related to those particles. So in this we can say that electron neutrino. Next part, determine the nucleon number and the proton number. Now you can see this question is very much basic question, right? Just like your IGCSE. So what is the nucleon number?
So the nucleon number is the number of protons and neutrons in the nucleus. So it's going to be 22, and then the proton number is going to be 11.
Okay, but in proton number, we discussed the concept of beta positive decay, right? They are asking about beta
Oh,
positive.
yeah, yeah. Okay, so after the decay.
Yes. So
So
in
what's going to happen is that it's going to I remember it's going to gain no, it's going to gain a neutron, right? So it's going to be
yes,
23. And then the number of protons is going to be 11.
11 or 10. Actually, in beta positive, your proton is converting into neutron. So we are having a one proton less as compared to the initial stage, right?
Okay, and then one neutron more.
Yes. So for proton number, we are having
23, and for proton number
no
it's going to be 10,
nucleon.
and nucleon number it's going to be 23.
A nucleon number will remain 22, right? Because
Oh,
your
okay, I remember
yes,
now.
because that is converting into different category. That is the equation.
Okay,
So
so the
we are
nucleon
getting
number remains the same, but the proton number is going to be -1,
yes.
whatever it is.
So actually we are converting this sodium to beta positive, and it is converting into a different nucleus. So your one proton is converting into neutron, plus we are getting electron neutrino also, right?
Right.
The next is the quark composition of a nucleon in the sodium 22 is changed during the decay. Describe the change to the quark composition of the nucleon. Did you get the question what they are asking?
Yeah, they're asking about the quark composition of the nucleon.
So they
What
are
what
asking about this combination, right?
Yeah.
So what actually is changing, your up is converting into down, right? The second point, up
Yep.
quark is changing into the down. So that is your answer in the formation of the quark. Changes into down quark. And the next part of the question, and you also observe that question is of only 6 mark, right? Because this chapter is not much detail just like the previous two, because those are combined from two chapters and this is only a single chapter. So that's why the weightage of the question from this chapter is less.
So it's just going to be like one question, and it's going to be like 7 marks only, not like 13 marks.
Yes. So a baryon consists of quark that are the same flavor. It means same type. The charge of the baryon is -2, where E is the elementary charge. Calculate in terms of E the charge of each quark. The question is, a baryon consists of quarks that are the same flavor type, right? So one more important thing, we are very important term in the question, a baryon, right? If you remember the category of baryon and meson. So baryon is made up of three quarks, right?
Yep.
So in this, you have to make with the help of three quarks that makes the baryon. So they are talking about a baryon consists of quarks that are same flavor. So it means their category will be same, their charge will be same. And the final is the charge of the baryon is minus 2e. Okay.
Okay.
So now they are asking where E is the elementary charge. So calculate in terms of E the charge of each quark. So we need to find out the charge. Mostly the questions is will be like in two form. One, they just give you the value of the charge and combine them, make a quark, right? Or the second thing is they just give you the formation or the formula of the formation and you need to find out the value. Okay, so basically a baryon is made up of three same identical quarks, right? So those are unknown, we don't know about them. So x plus x, it means there are three unknown quarks, right? You may take any variable, so that will be equal to minus 2e according to the question because it is given in the question, right? So they will be equal to 3x is equals to minus 2e.
Mm-hmm. And then x is equals to minus 2 over 3.
So this is in the term of E. Your charge will be equal to,
Minus 2 over 3.
okay, simple. If you just give you the value, so you can just take the reference from the value and find out the final composition. And sometimes they just give you the hint for that composition and you need to make a charge or you need to find charge by yourself. And final, state a possible flavor type of the quark. Your answer is minus 2 over 3. So you need to remember those names that are having a charge of minus 2 over 3e. Anti-up,
Okay, so
anti-charm, and anti-top, right?
yeah.
Because we studied about them. Yes, there is. Yes, because we know 2 over 3 are for up, charm, and top. So we are getting minus. So it means anti-up, anti-charm, anti-top. It may be anyone from this section, right? So you may just write. Okay, so they are asking state a possible. So it means they are not asking about a specific name. So you may write anyone. Okay, because they are only asking about possible. When they are asked about possible, so it means there will be a leverage for writing the answer. So it may be anti-up.
Okay, so I just have to like memorize these things in like
Yeah,
this part of this
yeah.
chapter.
So this is
Because it's
more.
like a 1 mark question, like it's 3 marks basically. So they accept any of these 3 answers. So I could have done any of these and they would have like given me the mark.
Yes, because they are asking with the reference of possible. So possible means it may be in any form. Just like in previous paper in IGCSE, if you observe in past paper, to draw a possible graph, right? So there is a range of answer that is starting from 2 till 2.2. If a student mark between these 2 points, so it is acceptable, right? So same goes over here. If you write from these three names, one of them, so it is acceptable, right? Okay, so now
Yeah, okay.
you observe that in single question, we just take reference from each topic that we studied till now, right? So they are like the theoretical one, you just need to remember the category and the name of that subatomic particle in that category and the charge for the quark. So that will help you to answer these questions, because we find the word baryon, so we just figure out that what is in the baryon, and then we just find out the name of the quark with the negative sign. So these are the things that is only related in this chapter. Sometimes they ask about the basic quantities, like the first part they are asking about nucleon number, proton number, but there is a reference of beta positive, so that's why it is slightly different from the normal one. Okay.
Okay.